All right. So in today's lessons, we'll go over some basic concepts. These are the fundamental concepts for our discussion in the following chapters. So basically, we'll briefly review the concepts of points, segments, rays, lines, planes, two-dimensional, three-dimensional, circles, and compass and straight edge construction problem, and axioms, theorems, and conjectures. Okay, so let's have a look at them one by one. So first of all, let's have a look at the points. Points are simple. According to the definition, a dot speck in geometry is a point. We can't do much better than the vague description. So what I want to say here is we typically denote points with capital letters, as you can see in the graph on the right. We use a capital letter P or Q, sometimes R, to denote a point. Okay. And also note that since you can't move your point in any direction, so a point is just a point, you can't move it in any direction. We say that a point has 0 dimensions. Okay, so be careful with this. A point have 0 dimensions. Any questions? No. Okay. Next is the segments, or sometimes they are also called line segments. Okay, first let's see the definition. A straight path connecting 2 points is called a segment, and our original 2 points are the endpoints of the segment. Refer to the segment by its endpoints, such as segment AB. We can put a horizontal line above the 2 letters to denote the line segment. And then we remove the bar to denote the length of the segment. So if there is no bar above the 2 capital letters, when you write just AB, AB denote the length of the segment. Clear? Okay, for example, in this graph, segment AB is denoted by capital letters AB with a bar. And if you do not include the bar, AB means the length of the line segment. Okay, and some related concepts are midpoint and equidistant. The point on the segment that is halfway between the endpoints is called the midpoint of the segment. So for example, in the graph on the right, we have a line segment X and Y, right? XY is a segment, and M is a midpoint because the distance between X and M and Y are equal. We also say that this point Hello, Dora, did you miss anything? Can you hear me? Okay, sometimes to denote that 2 segments are equal, you can put a stroke on this segment. For example, if you want to denote that XM equals MY, you can put a stroke here, right? And also in this graph, when you want to denote that ZX equals WY, you can put 2 strokes. That means ZX are equal to WY, but not necessarily equal to XM or MY, right? Okay, so these are some basic concepts about segments. Next, let's have a look at rays. Okay, first, the definition. If we start a point, then head in one direction forever, we form a ray, right? For example, as shown in figure 1.4, this is apparently a ray. We start from point A and then head in one direction forever. Or starting point is called the vertex of the ray. Also, the vertex is sometimes called the origin. So it's point A here is the vertex or the origin of the ray here. And we denote the ray using this symbol here. So capital letters A, B means 2 points on the ray. A is origin point, and B is some arbitrary point on the ray, and use a arrow to indicate this is a ray. Okay, the first point is the vertex of the ray, as shown here. A is the vertex of the ray. Okay, and in practice, we often leave off the little arrow here. Sometimes when you draw a ray, you can just draw a vertex and then extend indefinitely along one direction. So this is basically a ray, and this is a vertex. Understand? So this is how we denote a ray.
Yeah.
Okay, no questions?
No.
All right. Next one are lines. If we continue a line segment past its endpoints forever in both directions, we form a line which we write as line AB. So as shown in this graph, line AB means AB are the 2 points on the line, and this line can extend indefinitely to both, beyond both endpoints, right? And also sometimes we just leave off the little arrows here. It's not necessarily draw the 2 arrows. So if you want to draw a line, just draw a line, and then you can also specify 2 points on the line. So this is line AB. Also, to denote line AB, we use 2 capital letters that are on the line with bidirectional arrows to denote this is actually a line, right? And also sometimes we use a lowercase letter to denote a line. So also you can draw a line like this. You can denote it either using a line AB as this one, or you can use a letter, for example, K. So line K, okay? All right, next, some related concepts. If 3 or more points are on the same line, we say that these points are collinear. Okay, this is a concept of collinear. Collinear means all the points on the same line. And if 3 or more lines all pass through the same point, we say the lines are concurrent. Okay, these are 2 related concepts you need to remember. What does it mean by collinear, and what does it mean by concurrent? Okay, these 2 graphs shows these concepts. Clear?
Yeah.
Okay. And next, let's discuss the concepts of planes, 2D and 3D. Okay, for example, if this page or this screen were continued forever in every direction, the result will be a plane, right? Since we can move in 2 general directions, such as right, left, or up, down on a plane, we say that the plane has 2 dimensions. So for example, we have already known in algebra, we can use a 2D Cartesian plane to denote the plane, right? You can move either left or right or up and down. So we say this is 2-dimensional. And if we add a third dimension, for example, we can add a z-axis, right? So if we add a third dimension, we are in three-dimensional space. So for example, we can also draw a 3D plane like this. This is our y-axis, x-axis. Then we can add another z-axis, right? So this denotes a 3D dimension. And we will discuss some shapes in the 2D and 3D respectively. For example, in the two-dimensional case, we'll discuss triangles, squares, circles, and etc. And in the three-dimensional case, we'll discuss cubes, spheres, and some other 3D shapes in the later lessons, okay? All right, so these are some basic concepts. So now let's take a little exercise. Alice is thinking of a line. How many points on that line does she need to show Bob in order for Bob to know exactly which line she is thinking about? Okay, I'll give you 1 minute to think of this exercise.
Mm, 1, 2.
2 points, right? Because if you have only 1 point, what will happen? There will be indefinite number of lines can cross this point, right? So if you want to determine a line, you need at least 2 points, right? 2 points can determine a specific line. Any questions?
No.
Okay. Great. And you can also check the detailed solution on the lecture slides after this lesson, okay? And next, M is the midpoint of segment AB. Remember that this is a segment, right? And N is the midpoint of segment BM. If BN is 4, then what is AB? Okay, you can try to work this on a scratch paper. Okay, let me know if you solve this, okay?
Isn't it just divide by 2? Like the 2 points divided by 2.
Excuse me?
Isn't it just the 2 points divided by 2?
No, it says, for example, this is a segment AB, right? And M is midpoint, so M is here. Right? Can you hear me?
Yeah.
And it says N is the midpoint of BM. So where is N? N is here, right? And if BN is 4, so we know that this length is 4. And the question is, what is AB? This checks your knowledge about the midpoint.
It's 8.
8 or 16. So if NB is 4, what is MB? MB is 8, right? Because N is the midpoint of the segment MB, right? Can you follow me?
Yeah.
And because M is midpoint of AB, so what is AM? AM should equal MB, which is also 8, right? Can you follow me?
Yes.
Okay, so what is AB? AB is AM plus MB, which is 8 plus 8, which is 16, right?
Yeah.
Okay, so this question tells us that it's better to draw this a sketch of this problem in the geometry class. If you want to solve it, first of all, it's better to draw a sketch of the problem. Okay. All right, I'll give you. Okay, you can also check the complete solution after this class for this question. And this question is for you to complete after this lesson. This is a homework, okay? You can do it after this class.
Okay.
I'll leave it at home. And this is another homework. You can do this after the class. Okay, next, let's have a look at the definition of circles. The set of all points that are the same distance from a given point is a circle. So this is the definition of a circle, right? It's not very hard to understand. The given point is the center, okay? And the fixed distance is called radius, okay? We often refer to a circle by its center using the symbol, this one. So basically it's a circle and a point in the middle. And circle O is denoted by this symbol here. So circle O refers to a circle centered at O, as shown on the graph on the right. So this is circle, and we can denote it by using this symbol, okay? So this is a circle. And a line that touches a circle at a single point is tangent to the circle. So apparently, as shown in the second graph on the right, a line can either intersect with a circle or not, right? As you can see here, line K does not intersect with circle X here. And line L only intersect with the circle at point P, at only one point. And there is another line, MN. This line intersect with circle X at 2 points, which are X and N, right? So these are the possible relative positions between a line and a circle. If a line that touches a circle at a single point, then this line is called tangent to the circle. Okay, this is a concept of tangent. While a line that hits a circle at 2 points is a secant line. So there's another concept called secant. Can you see the difference? Tangent means touches at only 1 point. Secant means there are 2 intersection points. And a segment connecting 2 points on the circle is a chord. So as shown in this graph, the segment MN is called a chord. Okay, so this is a concept of a chord. And a chord that passes through the center of its circle is a diameter. So if I have a chord like this, For example, this is another chord, right? Let's say this is A, B. If this chord crosses the center point, then this chord is called the diameter, right? So this is a concept of a diameter. The portion of a circle that connects 2 points on the circle is called an arc. So there are a lot of concepts, right? So for example, if we want to denote this arc, this shorter arc, there is a shorter arc MN, right? If we want to denote a shorter arc, we can use 2 letters, just like this. This is arc MN. MN is a shorter arc. And if we want to denote, for example, a longer arc, such as from point P all the way to point M. So for example, if we want to denote this arc, this is also an arc, right? It's part of the circle. If we want to denote the longer arc, we can use 3 letters. P is a starting point, and we can choose any arbitrary point in this arc, for example, N, right? And then the end point of the arc M, and use these 3 letters to denote the longer arc, right? Okay, so let me make a summary here. As shown in this graph, OA is here, right? OA is called the radius, right? And MN, segment MN is a chord. And line MN is a secant line. So if you have a line MN like this, then line MN is called a secant line because there are 2 intersection points between this line and this circle. And L is a tangent line because L intersect with the circle at only point P, right? And if you want to denote a shorter arc, you use 2 letters. For example, arc MN is the shorter arc, which is highlighted in yellow. And if we want to denote a longer arc, for example, P from point P to point M as highlighted in green, we have to use 3 letters. Understand? Any questions?
No.
Okay, and there is another trivial concept called locus. What is a locus? Locus is the concept, the definition is the set of all points that satisfy specific conditions is called a locus. Therefore, a circle is actually a specific locus, right? Because a circle is just a set of points that whose distance is equal to the center point, right? Okay, so there's another concept called locus you need to know, okay? Shall we move on?
Yes.
Okay. All right, so you have already know there's some concepts about a circle. So let's do a exercise in this class. In the figure at right, and identify whether each of the following is a secant line or a chord or a radius or a diameter or a tangent line of circle O. If multiple terms are accurate, list all of the accurate terms. Okay, so we are given a diagram like this. And first of all, let's check line CO. Sorry, segment CO. This is the notion of segment, right? So, okay, I'll give you 2 minutes to have a look at this question, okay? And then I'll give you the solution. Okay, so basically we can make a table. Here, 1, 2, 3, 4, 5. Okay, so basically let's put yes or no into each of the boxes. Okay, can you write on the screen? Is it possible to write on the screen?
I don't know. I don't think so. Doesn't let me.
All right, okay. Actually, you can hit the alternate in the control bar. Did you see the control bar?
Oh, I see it.
Yeah, you can click alternate, then write on the screen.
What's a chord again?
Chord is any segment that connects 2 points on the circle. So in this graph, MN is a chord, right?
Okay.
So it has to be a segment first, and this segment connects 2 points on the circle.
Wait, my bad.
Okay, let me know if you finish, okay?
Okay.
All right, so let me show you the result. Okay, first of all, let's check segment CO. So this denotes a segment, right? There is no arrows in the no arrows for the bar. So this is a segment. Segment cannot be a second line, right? So we don't put a tick mark here. Segment CO, apparently always a center, right? From a center to any arbitrary point on the circle is of course a radius. So this is correct. It's not a diameter, right? Diameter has to be a chord first, and then this chord must crosses the center. So it's not a diameter. Of course, a segment cannot be a line, so it's not a tangent line. So next, segment, this is not a segment, this is line, right? Because there is a bidirectional arrow above the two letters. So this is actually a line. And let's check if EF only intersect with a circle with one intersection point or two. Apparently, according to the diagram, there is only one intersection point. So this is a tangent line, not a second line. This is not a second line. A second line has to be a line like CD, right? There are two intersection points. Do you understand?
Yeah.
Okay. And a line cannot be a chord, cannot be a radius, cannot be a diameter. So we don't tick any of these. And C is a segment CD. Okay, again, segment cannot be line, so we don't tick secant line or tangent line. Let's check if this is a chord. C is a point on the circle, D is another point on the circle, so the segment CD is a chord. This is correct. And if it is a chord, it cannot be a radius because radius is a segment from the center to any point on the circle. That's correct. And it's not a diameter as well. And it's not a tangent line. Okay, next one is also a segment between A and B, right? So segment AB is here. So note here, this is a special segment that crosses the center point. So apparently this is a diameter, right? So note here, any diameter is also called a chord. So you need to check this as well. Do you understand?
Yeah.
Because according to the definition, A is on the circle, B is on the circle. So the segment connecting these 2 points is called a chord. The difference is that this chord crosses the center. So it's also called a diameter. Okay, next one is a line, right? Line CD. So line CD intersect with this circle at 2 intersection points C and D. So this line is a secant line, not a tangent line. Okay. I think you confuse the concept between secant and tangent. So this is the secant line. Any questions?
No.
Okay, then let's see the next one. Okay, and you can also check the solution after this class on the selector slides, okay? And next page, let's do another exercise. Okay, for the same diagram, how to denote the shorter arc with endpoints A and D. That means the arc shown here. AD is an arc like this. This is a shorter arc between A and D, right? How do we denote it? And the second question is, how do we denote the longer arc with points A and D? The longer arc means this one, right? Okay, I'll give you 30 seconds to think about this question. Okay, did you finish?
I don't know how to do it.
Okay, I'll give you the solution. Shorter arcs are denoted with 2 letters, right? So in this case, AD as endpoint, so we can just use the endpoints AD and then put a arc above the 2 letters. So this means arc AD, the shorter arc. Understand?
Oh.
And to differentiate the longer arc with the shorter arc, if we want to denote the longer arc AD, we cannot use AD, right? Because if you also use AD to denote the longer arc, it's very difficult to tell if you want to describe the shorter arc or the longer arc. Do you understand? So we cannot use 2 letters. Instead, we use 3 letters to denote the longer arc. Also, starting from A, we can choose another point along the arc, such as B, and then the other endpoint D. So arc ABD means the longer arc. Make sense? So fewer letters for shorter arcs and more letters for longer arcs. Make any sense?
Yeah.
Okay. All right, then shall we move on? Are you making any notes?
Yeah.
Okay, let me know if you finish, okay?
Okay.
All right, then for the following question, I'll leave this to you for homework, okay? This is for homework. And the next question is also for homework. Okay, then let's check the concept of compass and straight edge construction problem. So this is commonly seen problems in geometry class. First of all, let's see the definition of the problem. Straight edge and compass construction is a construction of lengths, angles, and other geometric figures using only the idealized ruler and a pair of compasses. The idealized ruler, known as a straight edge, is assumed to be infinite in length, have only one edge, and no markings on it. That means you cannot use it to mark things on or measure things. The compass can be proved to transfer distance. Okay, so this is a basic concept of such a problem. And of course, when performing constructions with a straight edge and compass, you can only draw lines, segments, and circular arcs, right? If you have if you have only a straight edge, idealized straight edge, and a compass should look like this, right? We can only draw lines, segments, and circular arcs, right? We cannot use a ruler to measure segments. The operations you can perform are only these 5. For example, given a point, you can draw any lines through the point, right? That means given a point, you can use a straight edge to draw any line across this point. Okay, the second operation you can perform is given any 2 points, you can draw the line that passes through them both. You can just use a straight edge to join these 2 lines and establish the line like this, right? This is a second possible operations we can perform. Third, given a point, you can draw any circle centered at this point. So given a point, you can then use the compass to draw any circle that's centered at this point. Understand?
Yeah.
For example, use 1 foot on this center and the other foot to draw the circle, right? And the fourth possible operation is given a point and a segment, you can draw the circle with the center at the point and with radius equal in the length to the length of the segment. That means if you are given a segment, we can then use a compass to draw a circle that has a radius using this segment, right? This is also possible. And the last one is given 2 points. You can draw the circle length. You can draw the circle through 1 point such that the other point is the center of the circle. Okay. Any questions?
No.
All right, then let's see a exercise. Use your compass to find a point y on line K such that AB equals XY. You cannot simply use a ruler to measure segment AB, then use that measurement to find y. This is impossible, okay, because we don't have any marks on the straight edge. So is it possible to do so? I'll give you 1 minute to think of this question, okay?
Or just draw a circle.
Yes. First of all, you should use a compass to find this length on your compass, right? For example, we can use a compass to mark this length, right? Understand? And then put 1 foot of the compass here and the other one here and draw a circle, right? Draw a circle like this and the intersection point here and here. You will have 2 intersection points. We can mark them as A prime and B prime, right? Then X A prime should equal AB, or X B prime is also possible, right? It's also equal AB. That's how we find such point on the line. Do you understand?
Yeah.
Okay, you can also check the complete solution in this lecture slides after the class, okay? And let's do another exercise. Okay, so the following diagram shows 2 segments, AB and MN. And use your straight edge and compass to construct a line segment that has length AB plus MN. And again, remember that you cannot just measure with a ruler, okay? And second question, construct a line segment that has length AB minus MN. Okay? I'll give you 2 minutes to think about this question. Okay, did you finish?
Kind of.
All right, I'll give you the solution. So actually, first of all, let's consider question A. First of all, we can draw a line, use the straight edge, right? Draw a line, and then use your compass to copy the line segment AB on this line. This is possible, right? Can you follow me?
Yeah.
Okay, let's call it A about P and Q. So PQ equals AB, right? So this is our AB. So how do you find AB plus MN? Then we can use your compass to copy line segment MN, right? So we can draw a circle centered at Q, whose radius is MN, right? For example, let's call this C. Then PC should be AB plus MN, right? And this intersection is D. Then PD is actually AB minus MN, right? You see that? Any questions?
No.
Okay, and if you still feel confused, I'll leave this complete solution for you to read after this class, okay? I'll give you some reading materials. Is that okay?
Yeah.
Okay. All right, do read these materials, okay? This will help you understand this problem. All right, let's, okay, this problem is for you to do at home after this class. And there's another homework. Okay, last, let's check the definitions for axioms, theorems, and conjectures. So first of all, what is an axiom? An axiom, or sometimes called postulate, is a statement that is taken to be true without proof, to serve as a promises, to serve as a promise or starting point for further reasoning and arguments. So that means you don't have to prove a axiom, right? An axiom is can be treated as a accepted truth. And axioms can be combined to prove more complicated mathematical statements. We call such proven mathematical statements theorems. So basically, we start from some axioms. So axioms can help us to find some theorems. And this process we need to prove, right? And the proven theorems together with axioms can again help us to prove any further theorems, right? These are the relationships among different axioms and theorems. So you can only have a general concept of the terminology here. No need to deep digger, okay? We'll introduce some axioms and theorems for you to understand as we proceed to the following lessons, all right? And next is the conjecture. What is a conjecture? A mathematical statement that is not an axiom, but hasn't been proved false or true. Okay, note here, it hasn't been proved false or true is called a conjecture. Okay, I'll give you some examples. For example, these statements are all called axioms. Note that axioms are widely accepted truths. We don't have to prove, okay? First, any 2 points can be connected by a straight line segment. Do you accept this? Okay, this is a typical axiom, okay? You can use this to prove any further theorems. A second point, any line segment can be extended forever in both directions, forming a line. This is another axiom. So you can think of it as an atom in geometry, okay? Atom element cannot be divided any further. And point 3, given any line segment, we can draw a circle with the segment at the radius as, and one of the segment endpoints as center. And the fourth one is all right angles are congruent. Okay, we'll talk about the concept of congruent in the later chapters, okay? And another point is given any straight line and a line, given any straight line and a point not on the line, there is exactly one straight line that passes through the point and never meets the first line. Okay, this is another example of axioms. Of course, there are many others, okay? These 5 are typical 5 axioms we'll be using in our geometry class. And some examples of theorems are, for example, which you have already learned is the Pythagorean theorem, right? This is a theorem we need to prove. It's not an axiom, but a statement that has to be proved according to the axioms and proved theorem, okay? And next, let me give you some examples. Let me give you an example of a conjecture. So for example, a person named Arthur is making figures for an art project. He drew polygons and some of their diagonals. From these examples, Arthur made this conjecture. So this is a statement, right? If a convex polygon has n sides, then there are n-2 triangles formed when diagonals are drawn from any vertex of the polygon. So apparently this is a statement. We haven't proved this yet, right? We don't know whether it's true or false, right? At this point, we have not proved it, right or wrong. Therefore, this statement here is just a conjecture. It's not a theorem. Do you understand?
Yeah.
Okay. So basically, you need to know the difference between axioms, theorems, and conjectures, okay? Widely accepted truths are called axioms. From axioms, we can prove some statements. These proved statements are called theorems, right? And for any statement that hasn't been proved right or wrong, these statements are called conjecture at this point, right? Okay, So this is lesson 1. Basically, it's only about some terminology in the geometry class. The importance of we go over these concepts is that we need to use some common language to communicate our discussion in the following lessons. Okay, so I hope you can read through the lecture slides after this class and complete the homework and upload it onto Google Classroom. You understand?
Yeah.
Okay, I'll upload the lecture slides to Google Classroom. Do not leave yet. I need to make sure. Okay, I'll upload it in half an hour. Okay, you can check the Google Classroom. If you don't have any questions, you are free to leave. Okay.
Thank you.